Okay, here my system I installed temporarily. In the spring, everything gonna move in my shed outside. But for the purpose of demonstration, I assembled it here in the basement. I got my 5 batteries here connected in parallel to the bus bars. All the cables are at the same length, even though if I will have need a very short cable to go from that pole to that bus bar here, they are all at the same length in order for the battery to be uniformly used. Okay. Then each battery have a fuse. I also got a fuse here from the bus bar going toward the inverter. I got interruption switch here for when the power is off. I can send the power to the inverter, and that power, when the power come back, then I can switch the direction to the converter and open the switch to send the power from the charger to the batteries. And with that, the calculation I made based on what they say the battery are good for 1280 watt hour for the day. I was calculating that the system will be working for about 19 something hours, and I did a test. We connecting only the fridge and the freezer. As I mentioned, the water pump draws too much power for my inverter, and I don't know where I read that, but when I ordered that inverter, I was sure they were saying that the inverter of 1500 watt could take a 3000 watt surge for 30 seconds. So I said to myself, no problem if you go over 1500 watt for 30 seconds, it will not go up to 3000. So I thought, I was sure I was okay, but that's not what happened. When the water pump was starting, I could see it generated a 1700 watt surge and the inverter shut down. So I have to do my test only with the fridge and the freezer. And I tried to find back that information who said the inverter could take a 3000 watt for 30 seconds. I could not find the information. I must have dreamed it or imagined it, but somehow the information was not there. I will show a little video of the display. Very interesting. That inverter was a little bit more expensive because of the display, and I wanted to have more information. And the next inverter, well, now I'm thinking about increasing the size of the system, maybe not for the next few weeks, but in the coming year for sure. Now I have two choices. I could keep on the 12 volt system or go on the 24 volt system. To keep on the 12 volt system, I could add, I could add 5 more batteries here and duplicate the cable I have here, the cables I have here, and duplicate each new batteries will need a fuse, and the new system will need new cable, new bus bar. The charger here is good for 12 volt and 24 volts. I can keep the charger. The inverter here, the one I have, is only good for 12 volt. So I will need to change for 40 volt, 24 volt inverter. Anyway, excuse me. I will need to change that inverter eventually because, like I mentioned, 1500 watt is not enough. I will need at least a 2000 watt, and as well go for, I will think with 3000 watt inverter, I should be fine. Because even if I never need a 3000 watt, it will be good for the surge protection when the motor or the pumps are starting. And since the inverter will not work at full capacity, that will be more easy. It will be easier for the component of the inverter. They will not wear off as fast as if they were working at 100% capacity. But if I were to keep on the 12-volt system, like I said, I have to duplicate all the fuses, get new cable, get new bus bar, and probably new fuse, new connection, and made some calculation. For the fuses, another 5 fuses will be another $100. The cable here, as it is, it cost me about another $100. The bus bar, another $100. So just to keep on the 12 volt, I will need at least $300 worth of cables, fuse, and switches. And for that price, if I was switching to 24 volt, which I think I'm going to do, then I can put all the batteries beside here. Those cables are long enough to reach the positive pole of the next batteries. I will just need little 6 inches cable to connect from the positive pole here to the negative pole to the new batteries. All those cables will not even have to move, so I will not have to add new cable, only a little short length to connect the batteries here, as those big cables are long enough to reach. I will not need to add another bus bar. My charger here is good for 24 volt. It can charge for 12 and 24 volts, so there's no problem with the charger. And the inverter, as I mentioned, I will need to change it. As it is, it is not strong enough to supply all my needs. So I'm going to have to eventually change it. And from the $300 of cable, fuses, and bus bar, I will save if I go to 24 volt. For $300, I think I can get a 24 volt inverter that can go up to, I'm thinking more 3000 watt will be enough for my needs. Anyway, so this is like I said, this is the system. It's working very well. My test I did with only the freezer and the fridge. On paper, on my second video, I calculated that the power will last for about 19 hours. And doing a real test, it lasted for 26.5 hours. And the current draw was most of the time was about 300 watts, sometimes at 400 watts. And that's mean we're going to see on the paper, that's mean those batteries are able to supply more than the 1280 watts it's written on the battery. I think it's more like 1500 watt 1500 watt hour they can supply. So we'll see on the paper. And also when I was recharging the batteries after my test, I said, okay, I have to recharge the battery. Let's say in my test, let's say we are in a power outage, and my battery bank is now exhausted. I have to recharge it with the generator. So I connect the generator and use a battery charger to recharge the battery. This is a 75 amperes charger. And I read somewhere that you can add more than one charger to charge your battery bank. So I said, well, I have another 20 amp battery charger. So I hooked up the 20 amp battery charger by connecting it directly on the bus bar with the 75 watt charger. Here gave me a 95 amp charging power. I was going to 95 ampere to the bus bar, and by measuring each of the battery was receiving about 19 amp of power, which is those battery can take it no problem. So with 95 amp of power, it took about 6.5 hours to completely recharge the battery. It's still a lot, 6.5 hours to have the generator working all the time. But while the generator is recharging the battery, it can also supply power to the other device in the house. Let's say I want to cook something in the microwave or make a coffee. There would be no problem for that. Okay, this is a close-up of my installation. Here we have the 5 batteries, all connected in parallel with the bus bar. Each battery have its own fuse. Right now the fuse are 150 amp fuse. Maybe I should have got 125 amp fuse, but well, it will work from now. Each cable is a cable of gauge number 4, which is able to carry 150 amp of current. They all go to the bus bar. From the bus bar, there is the fuse to protect the inverter, which is right here. There is a switch to cut the power for maintenance and in case of emergency. And it is to be noted that I doubled all the cable going from the battery, the bus bar to the inverter. From the battery, they are gauge number 4, and I double the gauge number 4, which in the literature says it is the equivalent of a gauge number 1, which will be able to carry 300 ampere. And the thing to remember is the book says 2 gauge number 4 connected in parallel is equivalent of a gauge number 1. And when you go to get the connection to fit the cable together, make sure you get a cable connection for gauge number 1 and not gauge 1-0. That was my mistake. I ordered gauge 1, so by mistake I ordered gauge 1-0, which is way too big. So you need gauge 1. Okay, the way it works, let's see if we're going to turn it off right now. Let's see the power goes off, and then I turn the switch to send power to the inverter. Then I will turn the inverter on, and for the ease of use, I install an electrical box here connected directly into the outlet of the inverter. This way will be easier for me to go and plug the extension cord directly here than to try to find the outlet in the inverter, especially during a power outage when all the lights are off. So it will be easier for that. Right now everything is all manual. Like I said in my first video, I have a limited budget and I go in an incremental way, and as I go I will install more automatic device to do the switch and to connect directly my apparatus from the main power box. But until then I'm doing everything manually. Okay, let's see while it is working. After a while, if the battery goes down, then the inverter will go off, will turn off I mean. Then I will have to recharge the battery, either when the power goes back or if I start the generator. If I start the generator or the power come back, I have to recharge the batteries. So the thing I will do will be switching off the power going to the inverter, switching on the switch for the power to go from the charger to the batteries. So I charge that. Now the inverter, the charger will recognize the battery are there. You can hear the noise. And now the charger is charging the batteries. As you could hear, the charger turned off immediately because the battery bank is now fully charged. Yeah. So this is how it works. So as I go, I will increase the battery bank and put more automatic device to speed up and make the whole process easier to use. But right now it is fully operational, and this is the way my system is hooked up currently. Here we have a view on the screen that is situated on the inverter. It is to notice that not all inverters have such a screen. I decided to buy the model who have a little screen because I wanted to know what's going on with the powers. Here on the screen, this is has been recorded at the 24-hour mark. At the beginning, the voltage was reading 13.9 volt. Right now, it's at 12.3 volt. And the little battery design shows 3 bar out of 4, but that's more for lead acid battery, as lithium phosphate battery keep the voltage for a long time up until the end, where the voltage drop down very fast. Then the inverter will shut down because of low voltage. Here we can see the power used is about 400 watt. Sometimes we see it at 380 watt. Most of the time when I was checking it, it was at 300 watt. And we can see on the upper right, there's a 1 bar in the little box. This is how hard the inverter is currently working. At the stage it is right now, it is practically not working a sweat at all. It is running very cool, so much that the little ventilator in the inverter are not even turning on to cool off the inverter, which is good, because if the inverter does not work too hard, the component will not wear off so fast and the inverter will last a long time. Hello, so we're gonna do some calculation to check the performance of the system. I don't know if you recall my last video where I said I will need 5,784 watts per day to be able to have all my apparatus working for at least 24 hours. And with my 5 batteries, I will arrive a little short, but I will be able to manage. So this was theoretically by calculating what I had as information. With the test I did, I found out that I was able to continuously operate my fridge and freezer for 26.5 hours before the battery was too low and the inverter shut down. Okay? And most of the time, when I saw on the screen of the inverter, it was showing 300 watt of use, sometime 400 watt, but most of the time it was at 300 watt. Okay. And now for the calculation, let's say that most of the time was 300, but sometimes was 400 watt. Let's take a fictitious number just to be more representative of what really happened. So let's say it consumed 325 watt per hour for 26.5 hours. Okay. So that will give me, let me see, where is it? Okay, there it is. If I take 26.5 hours, multiply by 325 watt hour, that will give me 8,612.5 watt for the time. The time was 26.5 hours. And my goal initially was at least to have the whole system work for 24 hours. So the goal being successfully accessed. And now let's see what is the power of each battery compared to what they say on the books. So if I take that number, that amount of watt for the time being, divided by my 5 batteries, okay, I get each battery able to supply 1722 watt for the time being, before needed to be recharged. As in the instruction book of the battery, they say the battery is good for 1280 watt hour before needed to be recharged. So before the inverter cut down because the voltage was too low, that means each battery was able to supply 1722 watt, which is much better than what is stated in the literature. And then another interesting fact, to recharge my bank of battery, it took me 6.5 hours, which is quite long. And that while using 2 chargers, one charger of 75 amp plus another one of 20 amp, for a total of 95 amp for charging the battery. It still took 6.5 hours. It's kind of high and long, but I could try to shorten that time by getting another 75 ampere charger. That will give me 150 amp charging capacity, and for each battery that will give me 30 ampere of charging power per battery, which is acceptable. The instruction book for the battery say they can be charged up to with 100 ampere charger. So this is very interesting stuff, and I'm looking forward to doing the next one. And if you like that sort of video, please click the subscribe and the like. That will help the YouTube algorithm to put the video in a better position, and that will help my channel. So until next time, have a good day. Thank you. Bye bye.